We're talking about direct and inverse and joint variation. I kind of wrote, oh boy. Oh my. No, we cannot. It's physically impossible. Direct variation, sometimes it's called directly proportional, but the key word is direct. And what it means is when one of the variables goes up, the other goes up with it. So an example would be like, the more shoes you buy, the more you have to pay. Kind of a dumb example, but something like that. When one of the variables goes up, like how many things you buy, the other goes up with it, price. So like a really quick example would be if we bought 10 pairs of shoes and they were each $50. Let's say the cost of the shoes is $50 times each pair. So this is what direct variation looks like. Just some variable equals a constant times another variable. So the general formula is just y equals kx, but the k is a constant. It just depends on what the problem is. Some number is going to go in for that. Like in my example, it was 50 up here. Okay, but they could look differently. For example, if I divided by x on both sides, I would get y over x equals k. Like if I divided this by p, I'd get the cost divided by the price should equal 50 bucks. Anyway, so it doesn't always look like this. It could look like that. That's direct variation. One goes up, the other goes up. And then after that comes inverse variation. Or they might say varies inversely or something. Guess what that means? One goes up, the other goes down. So can you guys think of an example of, this is a little harder to think of, but an example of something, one thing that goes up, but one makes the other go down? I'm talking about numbers.
So like the more people go on a trip, then like the less money it'll be per person.
Okay, that's a good example. Like the more people you get to live with you in the apartment, the less you have to pay. That kind of, yeah, that would be a good one.
Yeah, and
Huh?
like our trip or something.
Oh yeah. Yeah,
The more cats you buy, the less mice are around.
yeah. Or how about this one? The faster you drive, the shorter time it takes to get there. Right?
That
Or
was
vice
10 times better.
Or vice versa. They were all correct. But so
I don't think true.
the driving one is kind of based on this formula, right? Distance equals rate times time. The distance, like if we were going to Tulsa, I don't know, it's like 43 miles or something. Usually it looks something like, if you divided by t, your speed would equal 43 divided by how long it took you to get there, or something like that. But usually the inverse variation looks something like that, like y equals k over x. So the constant of variation is there. But if you multiply both sides by x, it could also look like this. Like just basically like that. And then the last one is called joint variation, and all that means is the one variable is dependent on two other variables. So it's harder to think of an example. I could think of a geometry example would be very good. So it usually looks something like, x equals k times yz. So this is some constant, but there's just two variables over here. Okay, something else I should mention is So there's 3 variables altogether. The k variable is actually going to turn into a number though. So even though this looks like 4 variables, this will turn into some number. Okay, so one thing that we're gonna do, oh, I know what I was gonna say. Sometimes instead of saying like y varies directly as x, which would be like this kind of relationship, they might say like y varies directly as x squared, or the square of x or whatever. So this is still direct variation. They're still the 2 variables, or the cube of x, or the cube root of x, or whatever, but there's still those 2 variables there, so it doesn't really matter. But sometimes, you have to throw an exponent in on this. So, if we're solving something like, let me make an example. If a 50-pound grade schooler eats, let's say this is a direct relationship. If a 50-pound grade schooler eats like, I don't know, 6 ounces of food for lunch, that sounds about right, maybe.
5 cookies.
Then the relationship could be like 50 equals k times 6. So then they might ask, well, how much should a 150-pound high schooler eat? Okay, so, well, if you want to solve that, you could figure out k, like dividing by 6, and then plugging k in over here, and then solving for the food ounces or whatever. But the easiest way to do it is just use this little thing right here. Y over x should equal the same constant. So basically the way you set it up is just y over x equals y over x. Okay. So if they say if they give us like 3 numbers, like a 50-pound kid needs 6 ounces of food, so a 150-pound kid needs how much food? We're just going to set up a proportional. Okay, this for direct. And I wrote it over here. For inverse, it's the x times y should equal the same value. So it's more like, x1, y1 should equal x2, y2. So if it's an inverse problem, this is how it sets up. I know this is kind of a lot of info, but solving these problems is kind of basic. You just have to figure out how to set it up, right? So I wrote that right here, so under inverse. So this is like, if they just give you 2 numbers, this is how it would be set up. But if you're trying to solve for like the missing 4th number, that's how you set it up. You guys will see in a second. For joint variation, like if I divide by the yz, it would look like that. So you could do something like x over yz should equal x over yz. I didn't write that one on the board, but I kind of did. But yeah, there's not very many joints on this, but it does happen a couple times. Okay, jumping in. Okay, number 1 says classify each equation as a direct, inverse, or joint variation. Then state the constant of variation. So does number 1 look more like direct, inverse, or joint? It's
Direct.
Yeah. I wonder if I should maybe move the camera over. Inefficiency. Okay, so it's the 4, the constant is up top, so that would be more like, it does kind of look like this one, right? But since the constant is over here above one of the variables, it's actually an inverse relationship on number 1. So, and what is the constant of variation on number 1? 4. It's not a trick question, it's just the number. Okay, number 3, it's C over D equals 9. C over D equals a constant. Which one would that be? Okay, that would be like this. The constant, this is the number right here. So that would be a direct relationship on number 3. And 9 is the constant of variation. Number 5. Volume equals 1/3 base times height. Do you guys remember that formula? Huh? It's the volume of a pyramid formula. Oh, still up there, isn't it? They just did it. Anyways, so the volume is based on 2 variables, B and H. So what kind of... That's joint variation. And the constant is 1/3. Number 7, 3.5 times A equals B. So constant times variable equals variable. Yeah, that would be this one right here. I kind of put these on top because this is like the more normal way to write it, I feel like, but these are kind of like the secondary ways of writing it. But yeah, constant times variable equals variable. So that would be the direct relationship. And the number was 3.5. Constant of variation. Number 9. AB equals C, kind of a trick question. Any bright ideas?
Could it be direct or inverse?
Okay, this variable is dependent on these 2 variables, so that would be a what? Joint. 3 variables basically. So joint, but what's the constant of variation?
1.
Invisible 1, yes. That old trick. Number 11, write a function rule representing each variation. I'm trying to go a little bit fast because we need to kind of catch up with the other class. Yeah, anyways. If y varies directly as x. So, if we're doing direct variation, it's just y equals kx. But what we have to do is figure out what the k is and write the equation with that. So in the directions it tells us use y equals 2 and x equals 5. Alright, how do I solve that for k? 5 by 5. So k would be like 2/5. So what we need to write is just y equals 2/5 x. That's what they were looking for. Okay, and I'm going to help you on 12 too because there's only one of each of these, so we don't really have an example to look at. But y varies inversely. How does inversely set up? Like that. Y equals k over x. So, same thing, I'm just going to plug in 2 and 5. 2 was the y value, and 5 was the x value. How do I solve, get off the screen there, how do I solve this for k times 5? So k is 10, so what I'm going to do is just put in 10 where the k used to be. Okay, that wasn't, okay, 13. If y is directly proportional to x and y equals 26 when x is 4, find y when x is 6. Okay, the key word is direct. Directly proportional, varies directly is the same thing. So they're giving us like 3 variables. If these 2 happen together and this is happening, what's the 4th thing going to be? So that's when we're going to be using these equations. So for direct, we'll use this. and for inverse, we'll use this one. That's how we'll set it up. So direct just is a proportion. So it says y is 26 when x is 4. So 26 over 4 equals, now notice I put my y on top. Does it matter if you put y on top or not? No. But whatever you put on top on the left, you have to put it on top on the right. So you need to make sure it matches. So on 13 it says find y when x is 6. So where should I put the y at? On top, because this is a y value also. So they should both be on top when x is 6. And how did we solve these? Cross multiply. 4 times y equals 6 times 26. So 4y equals 104 divided by 4. Y is kind of some basic algebra. Okay, floating y. 15
Does
says.
6 times 26 equal 104?
Oh, was it 6 times 26? My bad, it's 4 times 26. 6 times 26 is,
150.
yeah, 156, there we go. 156 divided by 4 is 39. Okay, number 15. R is inversely proportional to S. So if it's inversely, we're using this one. So instead of xy equals xy, it's basically r times s equals r times s. So s is 16 when r is 2. Those two go together. Find s when r is 8. That's it. 2 times 16 is 32. Whoops. 32 divided by 8 is 4. (17) If y varies directly as the cube of x. This is kind of like number 13, but since it says cube of x, guess what I'm going to do? Y over x cubed should equal y over x cubed. Okay, so we're just going to have to cube the x's. So when I go to plug it in on 17, it says y is 108 when x is 3. So it's 108 over 3 cubed equals, and it says find y when x is 1. So y over 1 cubed. Well, what's 3 cubed? You guys remember that one? 27. And 1 cubed is 1. So when we cross multiply, we get 27y equals 108 times 1, 108. 108 divided by 27 is 4. Notice that did not get on the camera. Okay. 19. I think it's got a curveball. 19 says jointly, varies jointly. So I'm going to use x over yz equals x over yz. It's probably the easiest way to do it. But instead of x, y, and z, it's m, p, and q. So m over pq should equal m over pq. I guess I'll go ahead and write that down. Did they square any of these? I don't remember. No, they didn't. Okay, so m is 40, p is 1, q is 5. M is 40, P is 1, Q is 5. Find M when P is 4 and Q is 2. So this is 5 times m, 5m equals 4 times 2, 8 times 4 is 32, so this would be 320. 320 divided by 5 is 64. Let me help you guys set up 20 because it's a little bit weird. It says it varies directly as x and inversely as z. So y varies directly as x, look like that. But inversely as z basically means the z is below the verb, it's on the bottom. So the directly is kind of like directly across from the y, and the z is inversely, so it's flipped. So that's kind of how you set up 20. Okay, I guess if I solve this for k, like times by the z and divide by the x, then that would equal k. So you can kind of use this as your formula. Yz over x should equal yz over x. Because they should all equal the same constant, so they should equal each other. So this is how you set 20 up. It's kind of like 19. Okay, jumping to 25. The other class, of course, they're juniors, said they just finished talking about Charles' law, so they actually kind of knew what they were talking about. Charles' law, you don't really need to understand it. It's kind of an easy little equation. Charles' law states that the volume of a given quantity of gas is directly proportional to its absolute temperature. So in other words, when the temperature of the gas goes up, the volume goes up. Like, you guys know when gas gets hot, it expands. That's what it's talking about. But, so the gas temperature, see this is 25. Temperature is directly proportional to the volume. But actually I don't need this version. What we really need though is the T over V equals T over V. That's what we need. Temperature over volume should equal temperature over volume. So Kelvin is a temperature measure. Do you guys know that? It says determine the volume of a gas at 373 Kelvin if it occupies 2 liters at 273 Kelvin. This might be a little bit tricky. The 2 and the 273 actually go together, not the 373 and the 2. So it doesn't really matter what you put on top, but I put T on my little thing here, so I'll put 273 on top with the 2 liters on bottom. And then 373 is the other temperature, so it'll be on top. And the volume is unknown there. So 273 V equals 2 times 373. So how do we solve this? Just divide by 273, right? I think this is a decimal. V equals, it's a weird decimal. Well, it rounds to, I don't think they tell us where to round, but it rounds to 2.73 liters. Drag this back so I don't have to worry about it. All right. Number 27. Last one. Wait. 2 more. The frequency of the vibrations of a violin string varies inversely with the string's length. So in other words, the longer the string is, the fewer the vibrations. And what is that? How does that affect pitch? Do you guys know? Longer string, fewer vibrations, lower pitch. Yeah. Anyways, okay. Frequency and vibration. Frequency and length.
F and
Yeah. So, and it's inversely. So it's
equals
F times L equals F times L. Now we go plug the numbers in. 12.75 inches, 440 hertz. 12.5 times 440, 75.
No, I meant like 12.
Oh, that is, okay, it's 8.5 inches over here, sorry. Oh, that's the length, that's not the frequency. Okay. That's 7, no, what? That's not 75.
12.75 instead of 1.5.
Oh, okay. So anyway, whatever that is, we have to divide by 8.5. 660 hertz is the frequency. Guess that's a way of measuring vibrations, how quickly or slowly. Wow. 29. An object's kinetic energy varies jointly with its mass and the square of its velocity. So, kinetic energy, well, okay, it's a K, varies jointly with the mass and velocity squared. Is that what it says? But actually, I don't need that version. We need the K over mv squared equals K over mv squared. We need that version. So what are the numbers? You guys know why I put a square on the V, right? Because it said velocity squared, so square of the velocity. Object of mass 3 grams, 6 joules kinetic, traveling 2 meters per second. Okay, 3 grams is the mass. 2 meters per second would be the velocity. So that should be squared. And 6 joules of kinetic energy, that would be the K. Alright. And then it says, how much? No. Traveling at 2 meters a second. What is the velocity? So V is unknown. I think, but we have 24 joules for the kinetic energy. V is unknown. I think the mass didn't change, like they used 3 grams both times. So that's how you plug it in. Okay, I guess we'll just cross multiply here. 6 times 3v squared is 18 v squared. 2 times 2 is 4 times 3 is 12 times 24 is 240 plus 48, 288 I think. Divided by 18. Is that going to come out nicely?
16.
So the velocity is 4 meters per second. Well, it's not that bad. I just went really fast. Sorry about that. 30, let's look at that really quickly. An object's weight varies inversely as the square of its distance from the center of the earth. So, varies inversely, what formula were we using for that? Yeah. So, its weight varies inversely as the distance squared. So in other words, like as your distance from the earth gets farther, your weight gets smaller. But it's not like a 1-to-1, right? It's, anyways, so this would be the formula. This does have another little trick to it though. D stands for your distance from the center of the earth, not the distance from the surface of the earth, if that makes sense. You guys get it? So, if a teen weighs 140, how much will he weigh? Let's see. If a teen weighs 140 on the surface. So if you're on the surface, if you read the parentheses at the end, you're still 6,370 kilometers from the center. So, so if you're on the surface, you're still 6,370 is your distance from the center. And then the question is, what will your weight be if you are 100 or 630 kilometers above the earth? If you're 630 kilometers above the earth, you're 7,000 kilometers from the center. Just add those two together. So that should be 7,000 squared. Okay, give it a shot. I'll come around and see if you guys are getting it.